Okay, we'll try the last sketching a cubic equation one, at least of these first 6 questions, exercise 1. And here it is. Ooh, this has got a negative here. It's got a negative here, and that means it must be going down, and the computer knows it's going down, but I know it's going down because a is less than 0. Now, if we let x equal 0, gee, it's 2 again. 0, all of this becomes nothing, you get a 2. Then we let this whole thing equal 0. But we know, you try plus or minus 1, gee, it didn't work, but then I tried plus 2, and I put 2 in there, and it made it 0. That means x minus 2 is a factor. X minus 2 is a factor. Then you put down a big bracket. You put down the only thing you could put down to make it true. X squared times x is x cubed. And 1 times minus 2 is the only way you can get minus 2. Gee, you've got almost all of it figured out. It's just this problem in the middle. Now, it doesn't matter which one you can pick. You could look at the minus 6x squared. You got minus 2x squared right here on the inside. X times 4x, this thing times this is a linear term, always here. It's going to have to be minus 4x times x to give you minus 4x squared minus 2. That's the only way you could get minus 6x squared. Okay, there you go. Well, you know x equals 2 and 0. 2 and 0, not 1. That's a little typo there. It should be 2 and 0. X is 2. That should be 2 and 0. And this one doesn't factor. So you put b is minus 4, a is 1, c is 1 into the quadratic formula, and you get 0.27 and 0. And 3.73 and 0. When you look in Google Slides, that'll be fixed up to 2 and 2 and 0, but I don't want to worry about it now. Now the next question, those turning points at D and E, how do we do that? We find the derivative and we let it equal 0. That's how we find minimums and maximums, stationary points or turning points. That's how we do it. So we go f prime of x, well that's minus 3x squared plus 12x minus 9. And then divide everything by, let it equal 0, and divide everything by negative 3. You'll make it so much easier. That'll be x squared, that'll turn into minus 4x, and that'll turn into plus 3. And that's an easy little factoring thing from long ago. In what was it, grade 9, you learned how to put down x times x, and then ooh, something's wrong here. Maybe I'm going to go there because that should be a minus 3. Do you see? It's got to be minus 1 and minus 3. Another typo. You can see that has to be minus 3. Otherwise, you wouldn't get positive 3 there. And you need minus 4x, minus 1x, and x times minus 3. So that should be a minus 3. That should be a 2. But that should be a minus 3. And then, if that was minus 3, x would have to equal 3. And x would have to equal 1. And then how did we get minus 2 and the other point, 2? How did we get this minus 2? We took 1 and put it into the original function. And that's how we got minus 2. And if you take 3 and you go minus 3 cubed, 3 cubed, minus 3 cubed, 6 times 3 squared, minus 9 times 3 plus 2, you'll get positive 2. That's the local maximum. Turning point, stationary point there, and this one is 1 and minus 2. There's the whole thing figured out, and you can see this is what I typed into GeoGebra, the exact same thing. It gave me this nice equation. And oh, I almost forgot, what is the inflection point? Well, it looks like it should be right here, doesn't it, where it turns from concave down. I wonder if it is. Find the second derivative. And what do you get? Minus 6x plus 12. Take the derivative again. Make it equal 0. Add 6x. Divide by 6. Oh, it is. X equals 2 and 0. That's the point of inflection, where the second derivative is equal to 0 at x equals 2. So that means that's the place where it goes from concave up to concave down. I'll fix that in Google Slides there. But I think I'll leave it in the video because you can see that that's got to be a minus 3 and that's got to be a 2.